Welcome to the Geometry Final Review, Standard 12. Hopefully there will only be one part of this. We'll see though. Okay, in this one we're going to do area and volume formulas connections. This is the one where we kind of deal with scale factors. We've talked about linear scale factors, area scale factors, and volume. Remember, linear has to do with the kind of like the perimeter, the outside of it. Area has to do with the inside of it. And volume is if you kind of move it into a three-dimensional, how much will it hold? How much does it take to cover it? How much does it take to hold? So let's look real quick at this little example of at least the linear scale and the area scale. The linear scale factor between these two drawings, and I know they're not drawn well. If I'm going from 2 to 6, 2 times 3 is 6. So I know it's got a scale factor of 3. 3 to 9, still showing a scale factor of 3. Let me show you how I calculated that. I made a scale factor fraction, 6 over 2, which equals 3. And I also did 9 over 3, which equaled 3. So those are the linear scale factor. I could also do the perimeters of the shape, and I would actually find that they have a scale factor of 3 also. So those I think everybody's pretty good on. Let's look at what happened to the area though. When I multiplied by 3, well, this got 3 times as wide, but it also got 3 times as wide and 3 times as long. And so we're really adding a lot of extra. I mean, if I look at it, this is what I started with right up here in the corner. And I've added all of this just by taking it as a factor of 3, because I made it 3 more across and 3 more down. Now, let's make a scale factor out of our area, 54 out of 6. And if I put that up here, 54 divided by 6, I get a factor of 9. So it is 9. Remember, we talked about this connection, and we could do lots and lots of examples, but basically we said linear scale factor, 1, 2, 3, 4, 5, 6. Area scale factor, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. Volume scale factor, 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. Okay, I'm going to put these some other numbers in here real quick because we don't usually think of it as 1 square. We usually think 1, 4, 9, 16, 25, and 36. And I'm not sure I can do all of these. Let's see, 1, 8, 27, 64, 125, and I don't know what 36 times 6, 216. Now, whenever you're dealing with stuff, there's always a connection between them. The red shows you that connection. If the linear scale factor is 2, the area scale factor is 2 squared. Let's see if that held true. Linear scale factor of 3 should have an area scale factor of 9. Let's see if it did that. Linear scale factor was 3, area scale factor was 9. Let's look at and see if we can use the area scale factor. Let's see. 6 times the area scale factor equals 54. Hey, look, that's what we had right there. So we can use that area and scale factor. Now, this is the most common way that you will see it. Okay? Blobby Lake A, maybe something like that, has a, they'll tell you this perimeter scale factor, this is 2, and this one has a factor of 10. Okay, and this one has an area of, say, 100. So if I look at this scale factor, what's the linear scale factor? Linear scale factor is 10 over 2, or 5. Now, how do I find the area scale factor? Because this tells me how those are, but I know that there's a way to get from linear scale factor to area scale factor. And there is. I square the linear scale factor. So if I square that, I get 5 squared, or 25. That is the area scale factor. Okay? So what do I do with that area scale? Well, I scale area. Just like if I to take 2 times 5 to get 10, I can now take 100 times 25 to get the area of this one, which is 2,500. Okay, so that's how we usually see it. It's looking like we might have a part 2, but let's go on. Okay, so here's our problems. They're giving us all sorts of things. Remember, linear, I'm going to put it right up here for a moment. Linear scale, area scale is the linear scale squared. And the volume scale is the linear scale cubed. So if you get this and you need to go to this, it's easiest to go back to here, take the cube of it, and then go back up to the square. So it says the side ratios of these problems. Let's see if we can get in a little bit. The side ratio is 5 to 13. Then the area ratio, well, we know we get to the area ratio by squaring our side ratios. That's our linear scale factor. So let's see. 5 over 13 is how I'm going to write this, and I'm going to square it. Who remembers how to do that? Top, square both the numbers. So it's going to be 25 over 169. I don't think that's going to reduce to anything pretty, but let's see. 25 divided by 169. Yeah, that doesn't look very good. So I wonder if it'll reduce. Math, fraction. No, don't reduce either. So that's our answer right there. Then they say if the volume ratio is this really big number, then what is the side ratio? Okay, so volume is a cube to that. Because here's what we're going to do. We're going to do the volume ratio. 729 is to 728. And then we're going to do this. We're going to take the third root. Doubt you know how to do this, but here's how you do it. Let's do each of these individually. 729 cube root. And you do that on the calculator by doing 729 raised, and you put parentheses to the 1/3 power. Some of your calculators have a third power button, but I'm going to do 729 raised to the, I'm going to put in parentheses so it doesn't make any mistakes about knowing that I actually mean a 1/3 power. That's 9. That's pretty. That's 9. Okay, so the top's got a 9. And let's see what 1728 raised to the, parentheses 1 divided by 3. That, oh, go to. What did I do? You should be able to do that. Oh, I used the wrong kind of parenthesis. Figure that one out. It's 12. Oh, that's pretty. I like that. 9 over 12, which I know will reduce to 3/4. So the side ratio is 3 to 4. That's the answer for that one. Volume ratio, let's see, area ratio is this, volume ratio. So I'm going from one of these to one of these. So I think, just to make it easy, I'm going to go back to the linear scale and then up. It's just going to make it a little easier. Almost don't have space on here, so we've got to find a piece of paper. Here, we'll recycle this. Okay. So 36 over 49. And since that's an area scale factor, the way I get back to the linear scale factor is I take to go back there, I take the square roots. Square root of 36 is 6, and the square root of 49 is 7. So I know that the linear scale factor is that. Now, how do I get up to the volume scale factor? Well, it's going to be 6 to the 3rd, because I cubed the whole thing, and 7 to the 3rd. And I don't think that's going to reduce to anything nice, but we'll find out. Let's see, 6 to the 3rd power divided by 7 to the 3rd power. And then, nope, it doesn't look like it's really, it might be a little better, but 6 times 6 is 36. 36 times 3, I don't like that better. This is like 108 over 343. I don't know where it's getting that 216 from. Oh, 30, I don't know what's 6 to the 3rd power, 216. Okay, there you go. So we've gotten through problem 1. So I'm assuming that the other ones will show up in the next video.